Hello, this is Christian Idealism, and today I want to explain to you guys what is retroductive inference. So, retroductive inference is actually a kind of inference that most people have never really heard about, right? So, most of the three types of inferences that we are most commonly associated or most commonly understand in philosophy is deduction, induction, and then abduction, right? So, deduction is just you take the facts that you know and then try to just derive a conclusion. Induction is when you observe something and you try to make predictions about the future based on your past observations. And then abduction is when we try to build a theory. It's like a best explanation of the data. Retroduction is a little bit different in the sense that it involves all three of those elements. Okay, so it is kind of more technical. It's a more technical form of inference than other types of inference, but I'm going to explain it. So, how does retroductive inference work? Well, retroductive inference, in a sense, is very similar to abduction in the sense that you're trying to build a theory. Except in this case, in the retroductive case, what we have to do is that we have to actually posit what's called a theoretical entity, so an unobservable entity, something that we cannot observe directly, in order to explain what we do observe, right? So, for example, I'll just take one example from evolution. So, evolution is typically defined as natural selection, right? Now, the question is, do we actually directly observe natural selection? Well, not necessarily. We observe patterns of natural selection. So, one way to view this is, according to natural selection, we would say, or according to evolutionary theory, we would say that organisms that are less suited for their environment are going to die off, and then organisms that are more suited to their environment will thrive, right? So that's the idea behind natural selection. And because of that general principle, we can then make predictions about what we do observe in the life of organisms. And what's interesting is that we don't actually directly see, it's not like it's written out like, oh, this is how evolution plays out, or it's not like we see the force of evolution play out, but rather it's a pattern, it's a regularity that we observe in life. And what we do is we postulate this this kind of mechanism in order to account for the regularities of how organisms change over time, right? So that's the idea. And typically, retroductive inference involves both. It's going to involve all three, of course, but mainly it's going to involve deduction and induction, right? So typically what happens is we observe something, right? We observe some, let's say, an unexplainable fact, or we observe something that's surprising, right? We observe some pattern in nature, whatever that might be. And so what we do, okay, well, what best explains this behavior? What is going to best explain what I'm observing? What retroductive inference would tell us is like, hey, what you need to do, the scientists in this scenario, you need to posit an unobservable entity as a way to explain or predict what we do observe, right? And so, because of that, then when we posit that unobservable entity, then we can actually explain. So another example might be like gravity, right? We don't directly observe gravity, right? It's just a theory that we have to explain what we do observe, right? Or you look at quantum mechanics, like we don't directly observe the wave function, but yet it's a mathematical model to kind of explain how and why how subatomic particles in this case behave, right? Why there are probabilities and stuff like that. I don't want to get too much into that, but the point is, like, we use retroductive inference all the time in science. In fact, retroductive inference is the inference that makes science. Like, it is literally, like, that's how science works. So I think that science at its core is using retroductive inference. It's not just using induction, like what most people try to assume. No, it's actually using retroduction because what you have to do is like, okay, we have observations, and so we have to explain our observations, and in order to do that, we actually have to posit an unobservable entity to explain what we do observe, right? And then as we move forward, as we do more investigation, as we collect more and more observations, if those observations change or if we need to expand our theory, then we can do that, right? So going back to the evolution example, let's say that I have a theory of gradualism, which says that all mutations are random, right? But then let's say I observe an adaptive mutation. Well, that's going to change my theory in the sense that I have to now go back and revise my initial assumptions. So like, hey, now I have to include adaptive mutations into my, evolutionary theory in order to account for the data, right? And so in a sense, retroductive inference allows us to update our theories and allows us to learn new phenomena. It allows us to expand our theories. So as another example, like if you look at how we went from Newtonian physics to Einsteinian physics, Einstein, what he did is he had to posit this idea that space and time are one and the same, right? In order to explain, let's say, the mutation of I think it was the mutation of Mercury, I believe, that was kind of the issue with Newton's theory. But anyways, so what happened was, well, we had an observation that was surprising on Newton's theory, right? In this case, it was the rotation of Mercury around the sun. And so because there was this anomaly, this unexplained or surprising fact, right? This surprising observation, we had to actually come up with a new theory to account for the data, right? And it's not that necessarily it's not that Newton's theory was wrong, but rather it reached its limit in a sense. And so what Einstein had to do is he had to come in and basically change the underlying assumptions, and then from his framework, you can of course explain why Mercury goes around the sun in the way it does. And so because of that, like, retroductive inference, not only is it the inference that makes science, but it's also the inference that helps us to refine our theories, to make our theories better over time. And so, yeah, in that sense, then, retroductive inference is the inference that makes science, because that's literally what scientists have to do all the time in order to, when they're actually trying to build a theory to explain our observations. So yeah, I think that is what retroductive inference is, and that's just how it works. So if you have any questions, let me know in the comments. But hopefully now you have kind of a better understanding of what retroductive inference is and how exactly it works. So anyways, have a nice day.